Hey there, welcome to your 14th video tutorial for this programming language. And the first thing I said I'll do in this video is I'll show the recursive implementation for this. So for recursive implementation, if the input is like this arrow, STM, so I'll just return out 1, else I'll just, otherwise I'll return factorial of n plus SGM of n minus 1. Pretty much good. Just to show you guys that it works absolutely fine, I'll compile it, I'll run it, I'll run the third function obviously, enter the number 554. You see, oh, this difference, guys. 0 is the base case this time. So it's calculating form of our factorial from 0 to n. If I wanted it to calculate from 1 to n, the base case would have been 1. Or in fact, if the base case is 0, the value for it would have been 0. See, it's giving me 153 now. Anyways, just have a look at this now. Desktop A. I have this C. Create factorial, enter the number 9, something, and enter the number 6. That's exactly as we want a normal program to work. It's a distributable exe. Okay. So I had said that we'll be doing either classes or arrays in this video. So classes, arrays. These are the two options we have. Actually, I think both of the options are very good. But I have some time and will not be doing any of these in this video. The next video will be starting with arrays, probably, or maybe classes again. Now, right now I'll be explaining what time complexity was. I had talked about that in the last video. I mean, a couple of videos back. So, you know, for the Fibonacci series, I'll be building a program for myself and not for the users. So, it will be a pretty dumb one for now. Intense CNN, cout, fab of n. Fab of n is a function you guys know. So, int fab of int n, I'll be defining it right here. If n is the same as 1 or n is the same as 2, okay, is it the return n minus 1, return fab of n minus 1 plus fab of n minus 2. This is the recursive implementation of Fibonacci. What Fibonacci series is you have the first two terms defined as 0 and 1, and then any next terms in sum of the previous two terms, which is this will be 1, this will be 2, this will be 3, this will be 5, this will be 8, this will be 13, this will be 13 plus 8, 21, then 34, then 3, 8, 2, 5, 55, and so on. So, what I've just built is the recursive implementation of that. And I'll build another function int fibo of int n. Actually, this takes some time to build. Fibonacci no recursion. I have that thing built. I think actually some people started with. Hmm. Um, a space and fibbo of n. This first time I'll run it, for some other purpose it has to serve, except for explaining the time complexity. 3 and 8. Hmm. I get it. I hope it goes like I'm expecting it to go. Zero, one, one, two, three. It's fine. Okay, this is just for now, trust me. This is the iterative implementation. It's using loops. For time context, you think I'll print out just fib of n for now. Um, I will be bringing out fib of n. And I'll put in 30 here. It was instant. 40. It took some time. You noticed? What if it was fibbo? 40 was again instant. Um, Actually, there was a mistake. I'm sorry on my side. For the again instant. If it was fibbo of 45, it's instant. And if it was fib of 45, I'm not even sure it will be executed in this video or not. And it's taking time. And my time is running. And it came out. So that's the difference between recursive and iterative implementation. And we see that recursive implementation is highly slow. And that's what time complexity analysis is all about. We'll not be able to go into much details right now, but we'll be going into greater details later on. So anyways, just remember that this one is the recursive implementation, and for this one, this is the iterative implementation. Uh, Recursive iterative. Thank you for watching. Please subscribe to my channel. We'll be coming up with more and much better videos. But just remember, in case you want to implement the Fibonacci series, please implement it by the iterative one. Thank you for watching. Please subscribe to my channel.